Welcome to Placid Family. I'm Krishnakumar T, Faculty of Physics. And as we know, all those who are choosing science stream, we have 5 different subjects: physics, chemistry, mathematics, biology, and English. And one of the most important topic or the subject is physics for the science students. And in plus 1 we have 15 chapters, and also in plus 2 we have 15 chapters in physics. Now we are going to discuss with the fundamental topics of physics in class 11. Before starting the chapters, all of you must follow the consistent hard work in studies, because this is not an easy subject. You have only 5 chapters in class 10, like electricity, magnetism, human eye, like that. But in this case, we have 5 different chapters with hard concepts. So all of you must write the notes in a separate notebook. And consistent hard work is the only formula for success. Okay, now we are going to start with a new topic. The chapter is motion in a straight line. Motion and rest are the fundamental concept in physics, and this chapter deals with the major difference between what do you mean by rest and motion. Then distance displacement, that already discussed in class 9. Distance, displacement, speed, velocity, acceleration. These are the 5 fundamental things we are going to discuss. And in addition to that, one the kinematic equations. Kinematic equations like V is equal to U plus AT, S is equal to UT plus half AT square. We can derive these formulae on the basis of different methods. Now we have this chapter. So what is the difference between motion and rest? The first concept is rest. When we said a body is at rest, if its position does not change with respect to time and the surroundings, not only with respect to time but also with respect to the surroundings, then the body is said to be at rest. A body is said to be at rest when its position does not change with respect to time and its surroundings. The second thing is motion. So as we know, motion is a relative concept. That means if the position of a body changes with respect to time and surroundings, then that is said to be in motion. Motion and rest are relative. For example, if 4 people are traveling in a car, the car is moving with a speed of 30 km per hour, suppose. A driver, co-driver and 2 passengers are inside the car, they are sitting in the car, and the car is running with a certain speed, as we said, 30 km per hour. The driver, with respect to that driver, the other 3 passengers are at rest. Also, the co-driver feel the same effect. He felt that the other 3, the driver and the other passengers inside the car, are at rest, because with respect to them, their position does not change with respect to time and surroundings. Their surroundings is the interior of the car. They are sitting inside the car, and if the co-driver sees the driver or the other 2 passengers, he sees that the driver is always in his seat. But another person who is standing outside the car, he felt that the car is moving with a certain speed. So that is in motion. The same things are in motion and in rest relative to the person who is observing. If the person is observing outside the car, he felt that it is in motion. Like that, we can explain the motion and the rest are relative. Motion and rest are relative concepts. Okay, after understanding the concept of rest and motion, we are going to discuss with the very familiar two terms, distance and displacement. Distance is the total length of the path covered by an object, and displacement is the shortest separation between 2 points. For example, we have 2 points A and B. We can start from the point A and we are going to B. In 4 different paths, path 1, path 2, path 3 and path 4. In between A and B, we draw 4 different paths, path 1, 2, 3 and 4. In these 4 different tracks, A, B is directly separated in this path. The shortest separation between the points A and B is 3. So 3 is treated as the displacement, all other are treated as the distance or path length covered. So the total length of the path covered by an object is called the distance. The shortest separation between 2 points is considered as displacement. So the fundamental differences between the distance and displacement are: distance is a scalar quantity, displacement is a vector quantity. Therefore, distance is considered is always a positive quantity. Displacement can have positive value, negative value, and it may be 0. So distance, displacement. The other major difference is distance depends on the path followed, but in case of displacement, it depends only on initial and final positions. Distance has multiple values in between 2 points, but displacement has a unique value. These are the major differences between distance and displacement. To understand the concept of the difference between distance and displacement, we are going to discuss that one with a small example. An athlete running in a circular track, and he can complete the track in 20 seconds, and he is running with a constant speed. An athlete, suppose he is starting from the point A here. Initially the athlete is standing here and he is completing this track in each 20 seconds. What is his distance and displacement after 1 minute, after 5 seconds? These are the two things. So what is the distance and displacement? The first one is after 1 minute. After 1 minute means in each 20 seconds he can complete one circular track. That means after 1 minute, 1 minute means it's equal to 60 seconds. So he covered 3 times. He starting from A, after 20 seconds he came to A, and after the next 20 seconds he again came to A, and after the last 20 seconds he again came into A. That means displacement is equal to 0. There is no separation between initial and final position after 1 minute. But what about the distance? After 20 seconds, 2 pi r is completed. The r is the radius of the track, okay? R is the radius of the track. And after 20 seconds, he completed 2 pi r, circumference of the circle. After next 20 seconds, it will become 4 pi r. The last 20 seconds, it will become 6 pi r. So distance covered by the athlete is equal to 6 pi r. After 1 minute, displacement is equal to 0 and distance is equal to 6 pi r. And the second case is after 5 seconds. Since his speed is uniform, after 5 seconds, he reaches this point. We can take the point as B. After 5 seconds, he can move from A to B. So this is also equal to r. And what about the displacement? Displacement is equal to, we can join these 2 points A and B. Just to join the 2 points A and B, a right angle triangle is here. This is our base is r, altitude is r, then this is root 2 times of r. So the displacement of that athlete after 5 seconds is equal to root 2 times r. And what about the distance? Distance is equal to, the circumference of this circle is 2 pi r by 4. 2 pi r by 4. The quarter portion of 2 pi r is covered after 5 seconds. That is equal to pi r by 2. On the basis of this problem, we can understand clearly what is the basic difference between distance and displacement. Okay. After understanding the concept of distance and displacement, we are going to discuss with another topic called speed. This term is already you are familiar with this term. Speed is the rate of change of distance. Rate of change of distance means we are going to divide this quantity with respect to time. The distance with respect to time gives speed. Speed is equal to distance covered divided by time taken. As we know, speed is equal to x by t is the relation distance covered by time. SI unit of this one is, unit of speed is meter per second, and its dimensions are, speed has a dimension, is equal to dimension of distance by dimension of time. Distance is a type of length, so we use L as the dimension of distance and T as the dimension of time. Then dimension of speed is equal to L T raised to minus 1. 1 by T can be written as T raised to minus 1. So these are the dimensions of speed, rate of change of distance. What is meant by the term called the average speed? Average speed is one of the most important topic in this case. Average speed. Average speed is the ratio of total distance covered to total time taken, irrespective of the direction. The body can move in any direction. We consider just the total distance covered by the body by total time taken. Maybe that is in 3 or 4 different sequences. A bus is traveling with a certain speed along the same straight line, 60 km per hour for 30 minutes, and then it changes its speed to 40 km per hour, and then traveling to 30 minutes or 40 minutes like that. And what is the average speed? So average speed, first we must know about the total distance covered and then about the total time taken. So average speed is equal to total distance covered by total time taken. Suppose we have n different distances for the same body, then x1 plus x2 plus etc plus xn are the total distance covered in different intervals of time, like t1 is the time taken by the particle to cover the distance x1, plus t2 is the time taken to cover x2, plus etc plus tn. Thus we get the value of the average speed. So average speed is total distance covered x1 plus x2 plus x3 plus etc plus xn divided by total time taken t1 plus t2 plus t3 plus etc plus tn. Average speed can be calculated in different types of questions. We have to calculate the average speed of an object. If directly in any question, as you know that equation for average speed, if directly we get total distance covered and total time taken. Suppose x1 and x2 are the total distance covered by the particle in times t1 and t2, then we can use the equation average speed is equal to x1 plus x2 by t1 plus t2 for average speed. In this case, we have two different points A and B separated by a certain distance. In between these two, we have another point C. A and C are separated by a distance x1. C and B are separated by a distance x2. And to take a time t1 to travel from A to C and a time t2 to travel from C to B. In this case, we can directly use this equation average speed is equal to x1 plus x2 divided by t1 plus t2. Okay. And instead of this one, if we have the first special case we are going to discuss, if the same 2 points A and B are given, in between these two we have a point C. x1 and x2 are not given. x1 and x2 are not given. Instead of that one, it is moving with a speed v1 from A to C, and it will take another speed v2 to travel from C to B. Time is given as t1 time taken to travel from A to C. t2 is the time taken from C to B. So see the difference between these two. In this case, x1, x2, t1, t2 are given. But here, v1, v2, t1, t2 are given. X is not given. Distance x1 and x2 are not given. How can we calculate? The question is to find out the average speed. So directly use this relation we have already this one. Average speed is equal to x1 plus x2 by t1 plus t2. But in this case we don't know the values of x1 and x2. So must express x1 and x2 in terms of v1, t1 and v2, t2. So distance covered is equal to, we know the relation, velocity is equal to, or speed is equal to distance by time. By cross multiplying we get to distance is equal to speed into time. v1 is the speed from A to C. Then we can write x1 as v1t, x2 as v2t. Then average speed is equal to instead of x1 we can use v1 t1. Instead of x2 we can use v2 t2 by t1 plus t2. v1 t1 plus v2 t2 by t1 plus t2. Average speed. And if t1 is equal to t2, that is equal to t. If t1 is equal to t2, that is equal to t. The particle or the object will take the same time to travel from A to C, from C to B. Okay, then if t1 is equal to t2, that is equal to t, then the average speed can be written as average speed is equal to, take t as the common factor because t1 is equal to t2. That is t of v1 plus v2 by t plus t is 2t. The denominator is t plus t is equal to 2t. We can cancel t and t and we get the average speed in this case is equal to, average speed is equal to v1 plus v2 by 2. Average speed is equal to v1 plus v2 by 2. Second special case is that we have 2 points A and B, and the point C is in between A and B like that, and we have the distance between A and C is x1, distance between C and B is x2. Okay, but time is not given. In the first case, time t1, t2, x1, x2 are separately given. In the second case, instead of distance covered, speed v1, speed v2 are given. In this case, distance x1 and x2 are separately given. This take traveling with the speed v1 and v2 is the time taken to travel, velocity of traveling or speed of traveling from C to B. Time is not given. Time is not given. What is the average speed of the object is the question here. Then average speed in this case is equal to, average speed is equal to distance covered x1 plus x2 by t1 plus t2. This is a fundamental equation, but here we don't know the values of t1 and t2. Clear? Now we are going to express t1 as t1 is equal to x1 by v1 and t2 is equal to x2 by v2. Therefore, average speed is equal to x1 plus x2 by, instead of t1 we can use x1 by v1 plus x2 by v2. If x1 is equal to x2, that is equal to x, distance covered are same. First half of the distance and second half of the distance. If such type of problems we can deal as average speed is equal to x plus x by x is common in the denominator, x of 1 by v1 plus 1 by v2. X plus x is 2x, 2x by x into 1 by v1 plus 1 by v2. X and x get cancelled, and we have the equation for average speed in this case is equal to, average speed is equal to 2v1 v2 by v1 plus v2. Average speed is equal to 2v1 v2 by v1 plus v2. This type of mean is harmonic mean of v1 and v2. Okay.